This is lesson 5.4 homework aid. Now the main kind of question you'll see is, or looks like the following. And what we want to make sure is clear is that linear regression, when they ask for linear regression, that's also the same as asking for the line of best fit, and it's also the same as asking for the least squares regression line. So they all mean the same thing, and they do ask the same question with those three phrases, so I'm sorry about that. The first thing we want to do is make a scatter plot. Now, scatter plot always occurs in the first quadrant. It says we want to make sure that the years on our graph represent the years after 1985. So 1986 would be 1 year after 1985, and 2 years, and 3 years, and 4, 5, 6, 7, 8, 9, and 10 years. So that's what we're going to do on our graph. We'll just represent it that way. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1 year, 2, 3, 4. Alright. Now our y-axis is going to represent how, or what the length is of the zucchini. Now notice there's some typos here. This should be 31.8, this should be 33.8, and this one should be 35.5, and that happens on the first 3 or 4 questions. So make sure you make that change. Otherwise those would definitely be outliers. So for the first year, so basically let's look at our max and min for that, for the length. Looks like it gets as small as 29.6 and as big as 36.9. So we want to make sure that we have the y-axis covering those things. So if you remember, we're going to kind of make a little break here in the y-axis. We're not going to start at 0. We're going to start actually at, I think we're going to go 29, 30, 31, 32, 33, 34, 35, 36, and 37, and that should be enough. So this one is 29, 30, 31, 32, Alright, now if we plot these points, I'm going to zoom in a little bit here. If we plot these points, then 1986 is year 1, and that's 31.8, so about there. Oops, excuse me. Oops. Okay, fix that, sorry. Alright, so 31.8, so that'd be about here. And as we plot these points, remember, we'll just be as accurate as we can. So year 2 is 1987, that's 32.7. Year 3, 29.6. Down here, that's unusual. Not really with the other stuff. Next year is 32.8. 33.8. 34. 35.2. 36.9. Way up here. 34.4 and 35.5. Now notice they're not all in a perfect line, but they all generalize in a certain direction. So the line of best fit should be around there somewhere. Now if we use our calculator based on your blue sheet that you have, you should get a line of best fit, or a linear regression line, or a least squares regression line that is of the form y equals, and I get 0.54 x plus 30.7. Now that means my y-intercept is 30.7, So up here rather, my green line I wrote is an approximation. That's where it should be. And you have a slope that's about a half. So up 1 over 2, kind of something like that. So it would look kind of like this more. And that's the line of best fit. So basically, make your XY axes based on the information they give you. Plot your points. Use your calculators to find your line of best fit or linear regression line, and then graph it approximately on the data. And that's what you'll need to do. Except for one last thing, based on this question, you're going to want to predict the winning length in the year 2000. Now if this equation represents the years after 1985, then 2000 represents 15 years after 1985. So you'd plug in 15. So you'd say y equals 0.54 times 15 plus 30.7. And that would give you y equals about 38.8. And that's considered the length of what it's expected to be based on that line. It's not going to always be that. This is what's called the predicted value based on this equation. Alright, hopefully the rest of your assignment goes smoothly.